and what I'd like to do is talk about Firefly, which is a great new Hyperledger Labs project. And we always want to support the new Hyperledger Labs projects in the meetup groups. And so today we're very pleased to have both Peter Broadhurst and Nicko from Kaleido, who are joining us today to talk about this new Hyperledger Labs project, Firefly. And let me just give you a little background on Peter and Nicko. So Peter is the co-founder and engineering lead at Kaleido. He has 15 years of experience at the intersection of enterprise middleware, cutting-edge cloud architecture, and also mission-critical customer engagements. His specialist domain is enterprise middleware, and he's worked on every stage in the software delivery cycle in core messaging, application server, and integration of technologies that interface with blockchain. And he's also the author of a vast majority of the Firefly code database or code base that we're going to be talking about today. And then we also have the pleasure of having Nicko on. He's the software engineer at Kaleido, and he's also the open source community leader for the Firefly project. So those of you who want to engage with Firefly after this event, Nicko will be a good point of contact for you. His background is in designing, building, and operating enterprise SaaS systems at every layer of the stack. And he's also an innovator and technology evangelist who loves helping people learn about new technology. And he's also the primary author of the Firefly CLI that we're going to be talking about today. So at this point, I'd love to turn it over to you, gentlemen, and let you take it from here.
Thank you, John. Really appreciate it. So, Peter, I'll hand it over to you if you want, and you can go through Peter has a couple of slides, and then I have some slides as well.
So the goal today is to really give you an introduction. First, we're going to talk for not too long at a high level about the goals of the project, its status, what it's trying to achieve, really what makes it different and quite unique within the Hyperledger stables here. And we're then going to go into a more technical session about how you get started with it, the things you can use it to solve right now today. And Nicko's going to go through a great sort of technical presentation, but also we'll get down to some demonstrations of the APIs and maybe the samples as well. So that's the flow here. So if we wanted to kick off with the slides. Firefly is at its early incubation phase in the Hyperledger family, which means it's a labs project at the moment, and is actively working its way through to incubation stage as a fully fledged Hyperledger project. It has a very rich code base. There's a lot of capability already there, and the actual pedigree of the technology goes back for a number of years, and we'll talk a little bit about that. We move forward one slide here. I want to just give you a little bit of a high-level overview, and this is really also what we're going to talk through in this slide section around what Firefly is, what the problem that it's there to solve. And Firefly is not in itself a DLT technology. What Firefly is an orchestrator, an API server, a developer-centric platform with a user experience, CLI, and APIs to make blockchain tech work for a modern multi-party system. And this concept of a multi-party system is something that we're going to talk quite a bit about in this presentation because it's really where the blockchain technology is at right now. So we're going to move forwards one more slide. The interesting thing about the blockchain space at the moment is it's still nascent. In Kaleido, we've been in this, some of us, for more than the 3 years that Kaleido's been around, and the technology's been at the edge of wide adoption for that whole time, and it remains there, particularly in the enterprise sector. And there were a number of reasons why it's still in this nascent position. A lot of them are around actually the gap between the technologies out of the box and the needs of an enterprise network. You have the lowest of the low-level plumbing comes out of the box, a DLT, and you have to plug it together with all of these other, we found somewhere between 10 and 50 components you have to plug it together with before you have something that actually solves a use case in an enterprise context, where the amount you can actually put onto a completely shared DLT where the data can never be deleted, where the data is shared with everybody who's maintaining that ledger, even if it's a Fabric channel, you're going to have a number of people maintaining that ledger. That's a small piece of the puzzle. And if we move forwards one slide, the journey that we've seen played out time and time and time again is that a group of organizations trying to solve a problem in a new way, to build a multi-party system, comes together, and at the beginning they think, all we need to do is write some smart contracts and we're there. We'll deploy some stuff, everyone will run their infrastructure, and we'll connect together and we'll be done. You know, we'll have a few components, 4 to 6 months we'll be there. And the reality looks completely different. As you look at your use case, you look at the data involved, you look at the shape of the problem you're trying to solve, you realize we need a rich user experience, we need great APIs, we need to integrate back-end data. And actually, the blockchain can be used as one fundamental building block, one Lego brick that makes up the overall solution. But we need all this plumbing that just does not exist. How do we get these organizations to be able to come together and solve a problem? And actually this middle piece, what the job becomes is 10 to 40 components, 2 to 5 years in the making, and a real difficult journey to proving an actual piece of business value. We know from experience, because we've helped organizations do it within Kaleido, we know that it doesn't have to be that way. And the job ought to be, you model the things that are actually unique about your use case. You take tools that work off the shelf as engineers, that are built for you as developers. You put them together, you build your solution, and you go. That's the way everything else runs. That's the way you're used to building applications everywhere else. Why can't blockchain be the same? And if we move forward to one slide here, the reality of what you want to build in a multi-party system, what makes it and what it makes it valuable is what you need to build is a stack of software that includes the blockchain, also includes the off-chain private data exchange pipes that are needed for the non-blockchain pieces, also includes rich APIs, a local data store that's for your private data that you may or may not have shared with anybody in the network, gives you a complete picture of that, and provides you with great APIs that understand the core building blocks like tokens, that give you APIs that let you interact with the blockchain, not being a blockchain developer, so that you can build a network where each member can run this stack. The job of running it is achievable. Maybe run on a hosted platform like Kaleido. Maybe run just completely independently. But it needs to be easy to run. It needs to be suitable for the kind of enterprise data and core integration that you need to do. And it needs to let you build great user experiences, great APIs quickly on top of it, because the use case only exists once that's true. Move forward one more slide here. And I guess we find it pretty astonishing that Firefly seems to be the first open source project focused on this aspect of the problem. And it's really early in its life cycle with a significant durable code base there that's been seeded from a number of years of experience and production code from the Kaleido's background. But actually the community is just forming. We're about 6 weeks in to the forming of the community here. So this is a great opportunity to get in at the ground floor on an open source project, which is really trying to solve the taking the potential of these technologies like blockchain, like the more advanced compute technologies, and make them consumable for developers and ecosystems that want to solve business use cases, not build plumbing. So if we move forwards one more slide here, a parallel, and not to be too grand about it because we're very early in the journey here, we know for sure that the blockchain DLT space needs for it the same kind of acceleration that we got when Kubernetes formed on top of Docker. We think back to people like me who were using Docker in the very early stages, and you saw the sort of potential to take any piece of software and put it in a box, and suddenly that software could just be run and deployed. It seemed game-changing. It seemed obvious that this is going to change the world. But actually, anybody who built cloud services on it in the early days, you found you spent all of your time building the orchestration layer on top. And there were multiple orchestration layers in very, very early phases, and you could see how much work you had to do on your project before you could actually build anything useful. Now we're at a stage where it's just ubiquitous. You start from Kubernetes, you build your Docker, they bring them together. And what's fantastic about the Kubernetes ecosystem is it's pluggable to any cloud. It's pluggable to any storage. It's got all of the patterns there to be able to onboard all of the technologies, the operator construct. You can plug in anything you like. Suddenly, building projects in a cloud-native way is 100 times easier than it was when I was first building cloud services. And that's the journey that the industry's on, and we hope that Firefly can be part of that journey here. So what is Firefly in itself? So Firefly is an API gateway and a plugin infrastructure and a microservices architecture for building that stack, that set of software that needs to run that you can build a multi-party system application on top of. And really what a multi-party system is separate autonomous organizations that are running their own copies of the various application use cases, the UIs, the APIs, the integration capabilities. They're running their own copies and they're communicating. And almost certainly, because you're doing it in the modern era, you're building a modern business ecosystem, blockchain's the beating heart. And other advanced cryptographic technologies like zero-knowledge proofs, like trusted execution environments may be part as well. However, these are, because the whole value is these are enterprises that stay sovereign, have sovereign data, are running in a decentralized way, that guarantees, it's a 100% certainty that they're going to have a different view of the ecosystem. They're going to have different data that's unique to them. So what Firefly does, what a Firefly node is if we go forwards one, is we think of it a little bit like a periodic table of elements. It's a pluggable surface area to take all of this kit that you need, the blockchain nodes, the smart project contracts that you're going to plug in that have been built by others, like fantastic tokens projects for fungible and non-fungible tokens. Great projects that have been built in the low layers, zero-knowledge proof projects, etc. You can take those as building blocks. You can plug them together with the building blocks like private data exchange, messaging, large file movement, like great pieces of the puzzle like IPFS for sharing data that isn't suitable for the blockchain from a size and shape perspective, but is suitable for distribution to everybody peer-to-peer. And you can assemble them together. You can have a UI out of the box, a great API, which we're going to talk about a little bit later, that's designed for you as a developer, that conforms to sort of the modern principles that you would expect, is event-driven, so has things like WebSockets and webhooks built in, so that you can just get on with building your application, and it's pluggable. So by building to the Firefly API set, you aren't tied to a particular technology set. We move forwards one more here. One of the things that we really are making this true. This isn't just slideware. We've done this in previous generations and are doing it in the latest generation of the Firefly code base. Even the blockchain itself is pluggable. The big three are there. You can build an application that, for the standard things that should be the air and water of any multi-party system, being able to pin data, being able to sequence things, being able to put things in order in a block, in a sequence between a set of private parties, being able to share data on-chain and off-chain, fungible and non-fungible tokens. I think of them like the crud of a multi-party system, like you would have for a database: create, retrieve, update, and delete. Those fundamental constructs you can just build on top of the Firefly APIs and plug in from the community contributions of the big three, your chosen blockchain platform. And the same pluggability in databases, the same pluggability in messaging. So that you can assemble together those components and you can have an application built for Firefly. Now, a very important point here is that also you need that pass-through, so that when you want to expose and really utilize the unique features that are only there inside of a particular blockchain technology, custom on-chain logic for that particular technology set, features specific to them, but there's also a way to pass through, to break through the barrier and get to that full suite of technology as well. But you can see that this goal is less about building inside of these and more about an umbrella, a way to bring together these technologies, to break down some of the silos between the communities and to focus on the people building the apps. Not, as we are quite insular in the blockchain community a lot of the time, think about how cool the internals of the tech are. To say it's great that how cool that internals are, this best atomic swap contract that we've just built, that's fantastic. How do we make it so someone who doesn't understand atomic swaps can use it and get value of it? That's the goal of the technology suite. Move forwards one more slide. So when we think about what Firefly is, and we consider the fact that it sits sort of on top of the blockchain and around the blockchain, integrating that together with the off-chain pieces, the question becomes, well, what does it add, what does it take away, and what does it extend? And I just wanted to point out that it's both. It's about leveraging this fantastic capability that for my whole career was not there. This ability to have a shared source of truth between enterprises and to embrace the fact that that's true, leverage it, and extend it. So to take from the blockchain things like global ordering and finality that were impossible in the days of REST APIs and messaging when we were building these ecosystems before, and to make that available, and then to extend it with great REST APIs, built-in patterns that bring things together, to then combine that with data and all of the things about data that were true before blockchain, data that's unique to individual parties, data that's private, data that is very sensitive and regulated, data that is small and JSON-based and structured, data that is hundreds of megabytes or gigabytes and unstructured. Bring it all together, and on top of it, allow the pinning and the joining together of those technologies. And then to be able to build layers of process orchestration on top, to build genuine multi-party business processes in a simple way, using an event-driven model, and to pull in those constructs, the air and water of blockchain solutions like digital assets, tokens, NFTs, and bring them together to have pluggable identity, to be able to know who did what when in an ecosystem, while retaining the right levels of privacy and data sovereignty. So that's the goal. And then just the last slide that we're gonna talk through here. Sorry, there's two. Maybe just go on to the next one. I just wanted to talk about the evolution of this technology, and we'll see the user experience here. I'm going to see this in action a little bit later, but we move on to the next one. The journey that we're on, the phase that we're in the right-hand side of this, is the really exciting phase. It's the birth of Firefly. But we wanted just to give you the background that this isn't just a fly-by-night, brand new, flash-in-the-pan idea. This is the culmination of many years of real blockchain projects, learning what actually building a multi-party system means. Now, it's been seeded. Nicko and I are both from Kaleido. There's other organizations involved, and you can look at the Hyperledger submission. You'll see some of those sponsors from the projects themselves. It's come together from a lot of componentry, much of which is used in production today. But what we did when we went through sort of phase one of the plug and play services, and we went through and we built the first brain, which we call Kaleido Asset Trail, when we did the next generation for this Firefly, we actually rebuilt the core from scratch. Not all the plugin pieces, not the ecosystems for the different blockchains, not the off-chain components, but the core itself, we rebuilt it. And we rebuilt it so that it could be suitable for open source and pluggable. It could be the platform that fits a modern open source project written in Go, has a plugin architecture that really supports a community coming together and building something. So that's the journey that Firefly's gone through. And we've been really enjoying the collaboration over the last six weeks or so when we've been doing this as a group rather than doing it as an organization. And it's a really exciting time to get involved. So that's enough of me talking. We're going to now go onto the bit I think I'd enjoy if I was listening, which is we're going to talk about what it does, how it works. I'm going to hand over to Nicko, who's going to go through a set of slides and then a demonstration.
Thanks, Peter. Really appreciate that. It's a great introduction. So there's a lot that we could talk about in Firefly. I'm a software engineer and talking to software engineers, so this is going to be developer to developer here. The way I would like to approach this is to talk about some high-level concepts in Firefly. Then we'll look at some specific examples of JSON payloads of like, how do I do this in the system or how do I do that? Then we'll actually, I'll switch screens, I'll screen share, and we'll do some hands-on live demo stuff. So that's kind of how we're going to break it down. So to talk through some of these concepts, we have a small cast of characters here, which you may recognize from public-private key signing or other computer science stories. Alice, Bob, and Charlie. And so Alice, Bob, and Charlie work at different organizations. They all work in the same field, though, and their businesses want to do enterprise business transactions with each other, and they want to power it all with blockchain. So, Peter already gave a great introduction to, what is Firefly, so I won't spend a whole bunch of time on that. But, it's essentially, Alice and Bob could deploy blockchain nodes and, set up a private chain, but then, how do they actually get data back and forth? Or there's a ton of infrastructure that you need on top of that to have an effective enterprise multi-party system, and that's the gap that Firefly seeks to fill. It's it is a standard that organizations can use. Alice can run a Firefly node, Bob can run a Firefly node, Charlie can run a Firefly node, and then they can all collaborate together. They can run these enterprise transactions. There's a ton of different things that they can do, and we'll touch on each of these in detail in a little bit. But there's options for sending data publicly or privately. Things can be pinned or unpinned. There's both event-driven and request-reply models. There's lots of features. There are some features that are still in the works, such as fungible tokens, non-fungible tokens, and custom on-chain logic. But there's a lot that's already there. So we're going to start with, what's here? What can I do with it today? So the first thing that I think is probably makes sense to talk about is like how do I get data from one person in the network to the other? So in a Firefly network, we talk about we sort of use the terms member or organization interchangeably. So Alice, Bob, and Charlie are all members of the network. And they're at their respective organizations. So Alice has a piece of data here that she wants to distribute to all of the members of the network. So she can do that via a broadcast. It is a public message. Anybody can see it. The hash of it will go on the blockchain, and it will be there for anybody to look at. So that's great when you want to just announce something to everyone else in the network. But what if Alice has a piece of data that she only wants to send to Bob? Well, you can do that too. There's a different API endpoint that you can use to privately send data to one member or a group of members, and you can select who has access to that data. So those are kind of the main concepts of, you can broadcast or you can send privately, and we'll look at examples of how you do each of those here in just a little bit. The next thing, kind of decision point you can make is whether you want the data to be pinned or unpinned. So in the case that it's pinned, it gets pinned to the blockchain, but maybe there are use cases that you don't want that data to go to the to be pinned to the blockchain, and so there is a separate API endpoint, or sorry, a separate transaction type for that as well. In either of these combinations, you can send either JSON data or blob. It can be a binary file. That data can be inline in the request. Sorry about that. My camera has. Okay, I think we're back. My camera froze there for a second. The data can be inline, or it can also be linked, and the data can be made public or private for either of these. So now I want to talk about just a couple of interaction models with the API. The event-driven model is probably what we expect the 90% case to be used. And so the event-driven model, it allows for higher throughput. So if you're used to building asynchronous applications, this will sound familiar. So Alice has a piece of data she wants to send to Charlie. Prior to her sending this data, actually, never mind. Sorry, I was. We'll get to that in the next slide. So Alice has a piece of data she wants to send to Charlie. So she makes an HTTP post to the Firefly API. For the sake of this diagram, I've simplified the communication here. So their Firefly nodes talk, but once Alice's Firefly node has received the data, she immediately gets a 202 accepted back, and that says that Firefly has received her request and it will process it. At some point in the near future, Charlie's Firefly node receives that message and then sends the message to Charlie. It could come over a WebSocket or a webhook, depending on what Charlie's application is set up to receive. Once Charlie has received and his Firefly node has processed the message, Alice will get a confirmed event back, and that's how she can be assured that Charlie has received this message, and whatever he decides to do with it at that point is up to him. Like we talked about, these can be pinned or unpinned. The data could be JSON or blob, and all of those things apply here in the event-driven model. There's also a request-response model. So, if Alice is building her application to make a request and expect something back in return before she moves on, you can use the request-response model. It is obviously going to be higher latency, as we described the flow. You'll probably see why, but Alice makes a post request to the Firefly API that she does not immediately get a response back. Instead, what happens is Alice's Firefly node transmits to Charlie's, and then Charlie, at some point prior, has set up a subscription. We'll talk about what subscriptions are, how to set them up in a little bit. And he will receive this message over a webhook. His application will respond with an HTTP response. This could be an app that's designed specifically to work with Firefly, or it could be a legacy system or just some other HTTP server. But as long as there's something on the other end that responds with an HTTP response, Charlie's Firefly node will wrap that up. It will send it back to Alice's node, and then she will get the 200 OK with the payload of whatever Charlie sent. So that's the request response model. You can see how it's obviously going to be higher latency because there's a whole bunch more hops here involved until the response comes back to Alice. I just want to very briefly touch on the plugin architecture of Firefly and kind of highlight some of the pieces in it. Peter alluded to some of this earlier, but so Firefly is designed as a microservice architecture. And so there is a Firefly core. The core is written in Golang, but Firefly itself is a system that has a whole bunch of different parts to it. And all of those parts are swappable via plugins. And so it's extensible, it's customizable if you have specific needs for a certain technology that may be optimized in a different way than an alternative. You can write a connector to connect to that plugin very easily. So everything from the blockchain layer, right now we support Ethereum out of the box. And I realized, sorry, I thought I had a spelling mistake in I hand wrote these slides, so there's no spell check on paper, unfortunately. So we support Ethereum out of the box. Fabric and Corda support is in progress, in active development now. On the database side, we support PostgreSQL and also SQLite. For public storage, we support IPFS. It makes sense. It's a distributed public file system, so it's the perfect fit for building distributed, decentralized business applications. But other things such as the identity system, the data exchange, and the event transport are all pluggable as well. So it's really cool architecture, and definitely love to see where the community takes this extensible architecture in the future in integrating with other systems. Okay, a couple other concepts that I want to talk about just real quick, and then we'll actually look at some real examples, I promise. So namespaces. Namespaces in Firefly are a great way to segregate data or just group messages and data types that are related to a certain thing. There is a default namespace that is available out of the box, or you can define custom namespaces. The namespace can be advertised to everyone in the network, and then all the other members will be aware that that namespace exists and messages might be coming in on it. Reasons why you might use a namespace, they're useful for testing. So you might have a test namespace where you run some transactions to just make sure your network is set up correctly, or you might be running a test app to exercise it. But you don't want all of those transactions and messages sort of polluting the main data space for your application. It uses blockchain. So if you run a pinned transaction, it's there forever. So the namespaces give you a way to sort of group data that you may not want to see in your main application. Or you may be running multiple apps. You may be running sort of a multi-tenant system. A namespace is also a great way to group the data by application or by tenant or that sort of thing. So you'll see in all of the API endpoints that we look at, most of them will all be prefixed with a namespace, and so that's what that's there for. Next concept is messages. This is in the world of computer science, the word message is rather overloaded, but Firefly has its concept of a message. So everything, when Alice wants to send Bob data and Bob wants to reply to Alice, all of that data goes in a message. So I can send Firefly a message, and Firefly can notify me of messages that have been sent to me as well. A message can have multiple data elements. There's a header section where you can define information about how the message should be delivered and that sort of thing. And we'll look at some examples here. Actually, I believe that is my next slide. So we're going to shift gears now and look at some JSON. After we look at just a couple of examples, I'm going to share my screen, and then we'll actually try it. And fingers crossed that live demo will actually work the way it's intended to. It's always exciting. So this is the simplest of simple messages that you could send in Firefly. I could post this to the broadcast message endpoint, and that would send the string "Hello World." The value here could be a JSON object. I've just made it a string to make it simple. You'll notice data is an array. So if I wanted to, I could actually send multiple data elements all in one message. This is still one message, but I've just attached two different pieces of data to it. So I could broadcast that data if I posted it to a broadcast endpoint. But what if I just want to what if Alice just wants to send a piece of data to Charlie and not Bob in the network? So maybe there's a piece of secret data, doesn't want to advertise to the entire network. There's a separate endpoint for that. And then within the payload here, we have this new group object that we've added to the message. Within the group, we have a list of members, and we put the member's identity here. In this case, Charlie, we'll pretend is an identity that's registered on the network. And Alice could send this message just to Charlie, and it would not go to Bob. You'll probably notice that members is an array. So if I wanted to send both to Bob and Charlie, but not Frank or somebody else that might be on the network, you could extend this by just adding more identities to the list of members. Okay, let's talk about a couple other concepts on messages. So messages can have a tag, and a tag is intended to indicate to the other members of the network how this piece of data should be processed. You could think of it as kind of like a function call, or what it is an indication to the other member of what they need to do with it. So in this case, maybe we have a customer order, and the payload here is the data about the order, but we set the tag to new order placed to indicate to the other members of the network that this is a message about a new order that just came in, rather than maybe a message about an order being returned or canceled, in which case the data would obviously be treated very differently in those cases. So that's what a tag can be used for. Messages can also have topics. Topics is an array. You can have multiple topics. That's a little bit more of an advanced topic. Sorry, terrible pun or use of word. So in this case, kind of building on our customer order example, we can use the customer ID as a topic. And what this will do is it will ensure that messages that share a same topic are ordered and need to be confirmed and acknowledged in the order that they have been ordered on through Firefly's ordering system powered by blockchain. So if there is a default topic that is used if you don't specify a custom topic here, but that's a way to sort of maybe you have lots of customers that are at various steps in a flow. You can isolate those so that one doesn't block the other while they're being processed by using separate topics here. All right, another example. So you're kind of going back through my earlier slides. We talked about how you could pin transactions to the blockchain, or you could have them unpinned and have them off-chain if you needed to. So this is how you do that. There is a back in our header section on the message, you can define the transaction type. If you set that to none, that will indicate to Firefly that so the options right now are batch pin or none. And so none means don't pin this to the blockchain. This is an off-chain operation. And so in this particular case, I'm transmitting top secret data to Bob. So this would be a private message send that is not on the blockchain. And this would only go to Bob. Okay, that is it for my slides. At this point, I'm going to shift gears here and share my screen and hope that our live demo works here. All right. I should be sharing my screen. Peter or someone else on the call, can you just give me a quick thumbs up? Okay, excellent.
Yeah, you're sharing your screen, Nicko. Looks good.
Excellent. Thank you. Appreciate it. Okay, so as a developer, when I'm learning about a new system, I like to get hands-on. I like to actually try it. I like to run it all on my own laptop if I can, and that's exactly what we've built the Firefly CLI tool for. So Firefly CLI, this is the GitHub repo for it. It is written in Golang. You can install it by running go install. We have plans to distribute binaries like through Brew and other package management systems, but for now you can install it through go install or go get. And I'm going to show you what the CLI will do right now. So the CLI is designed to build a local test environment. We call that a stack. So I can create a new stack by saying FF is the binary name for the Firefly CLI. I can say FF init. I'll run that, and it'll ask me, hey, what do you want to call this? We'll call it demo. And it'll ask me how many members we want in the network, and I'll say 3. So it's generated here a Docker Compose file for me. I'm going to go ahead and start it, and then while it's starting up, I will describe what it's doing. So I can go FF start demo. Okay, so the Firefly CLI wraps Docker Compose, and we're using Docker containers for all of the parts of the Firefly system, all of that periodic table of elements that Peter talked about. All of those different things are going to run in various containers. So for each member of the system, there is a Firefly core, there is an IPFS node, there is a data exchange, there is a blockchain connector. In this case, the default out of the box here is deploying an Ethereum stack, and so it's going to use Firefly ETH Connect as the connector there. There's one blockchain node that they all end up sharing just to reduce the number of containers running. And the default out of the box is also to run with SQLite. You can choose if you want SQLite or Postgres when you set it up. Again, to just keep the number of containers down, we went with SQLite out of the box. So you can see my containers are coming up. It's now doing the registration, so it's registering each of the organizations and nodes with the other members of the network, and we should be wrapping up here pretty shortly, and then it will print out some more information on how to actually look at what it created. Okay, there we go. I timed that just right. So it says we've got a web UI for members 0, 1, and 2. So, continuing on with our cast of characters here, we'll pretend 0 is Alice, 1 is Bob, and 2 is Charlie. So I can go here. I'm just going to open up each of these interfaces, and then I'll try to. So you can notice that they're all running on localhost because this is all running in Docker on my computer, but they have different port numbers. So I'll try to. I realize there's going to be a lot going on here, and I'll try to indicate based on the port number whose screen we're looking at. So this is Alice's Firefly UI. So this is a UI explorer that comes out of the box with Firefly that lets you see, we can see there's 3 members in this network. We can see the history of messages and transactions and data that has been sent through the system. And so over here we've got, this is Bob and this is Charlie. So now I'd like to hop over to Postman and actually start making some requests. Oh, before I do that, I want to point out, I just want to make a quick call out to the docs in case you want to find out about the API. You can go to labs.hyperledger.org/Firefly. The API spec is right here on the page. You can also get to this through the, if I go to one of these nodes, instead of UI, I can go API. This will also give you, this Swagger is actually generated by the application. But if you don't want to set up a whole stack and run the application, you can go here and see the same exact thing. So you can just browse to this page and see these are all the different endpoints on the API. So the first thing we're going to do is we're going to broadcast a message. So that's going to be a post to, I've made my font a little bigger here so you all could read it, and it's kind of cutting it off, but namespaces /broadcast/message, excuse me. So, like I said, this is the original example that I had, which is the.
Maybe just make your font size.
Make it a little bigger. Okay.
Yeah.
Yep. Is that better? No, that's fine. Thanks for the heads up. All right. Hopefully that's a little more readable. This is the what I call the simplest message ever. So we're gonna. This is a post to broadcast message, and we're just gonna say hello world. I'll hit send, and then so. Just to describe our story with our cast here, this is port 5000, so that this is Alice broadcasting to the rest of the network. We'll hop back over to Chrome and look at, okay, so we see in Alice's UI, we can see there's one message that has succeeded. We should be able to go to Bob's UI, and he sees the same exact thing, and so does Charlie. It was a broadcast, so they all got that message. We can go to the data tab and look at it, and we can see there's the message. It says hello world. So the actual payload of the data was stored in IPFS, and this was an on-chain transaction, so the hash of it there is on the blockchain, and there we can just sort of look at the whole thing. So this is a great way to see kind of what, as you're testing your application, you can peek at the network from the perspective of any of the members on it and kind of see what is going on under the hood. All right, so that was the simplest thing we could do. Let's try something else now. So let's say Alice has a piece of data that she wants to send to Bob. In this case, Bob is org1, but we're still, this is Alice's API that we're using here. So here we're going to post some secret data called a secret message. So we should see this message show up on both. Alice can see that she sent it. Bob can see that he received it. Charlie should be completely in the dark to what the message was. And indeed, there we go. So there was also another thing that happened here. There was a group init that went through. So that's basically Alice's Firefly node saying, hey, I'm sending a message to a select group. I need to define that group ahead of time before I can send messages to it. And that's why you see that. That's why our message count now is up to 3, because we initialized the group and then sent the private message. So this is Alice's UI. Let's hop over to Bob's. Bob sees the same exact thing over here. You can see the same message. This was pinned to the blockchain, and we can go to data, and we can see our secret message there. Now, so this is Bob's UI. The message was sent to him. If we go look at Charlie's UI, Charlie has no clue what just happened. He does not have a message about that. So that's an example of sending private data. All right, let's look at, so this is, if I wanted to do the same thing but not pin it to the blockchain, I could set the transaction type to none. Let's see, for the sake, I want to leave a little time for Q&A. So for the sake of time, I'm going to skip ahead. So I want to show the request response model as well, because that's kind of interesting. So backing up for a second here, what we're going to do is Charlie is going to set up a subscription. Charlie's going to set up a subscription to send events for a certain topic to just an API, some URL on the internet. That happens to be this request bin that I have set up here. So basically, HTTP requests to this address will show up here. If you're watching, please don't make spammy requests to my URL during the demo. Thank you. Essentially, this is what creating a subscription looks like. We will make a post to /subscriptions, and we'll say we're going to call this fictitious example. This will be the banana handler. So anything with the tag banana will go to this endpoint. We can define some options on the subscription. So this is where it will go. So it's going to go to my request bin address /banana. We want the reply on it, and then we're going to tag the reply with a banana response. So that will come back with the tag, which Alice could have a subscription set up to handle that a banana response in a certain way as well. And we want it to make a post to there. So this is what a subscription looks like. We're going to post this to I think I said Charlie earlier. I'm actually going to. This is Bob's address now that I'm checking it here. So Bob's going to set up the subscription. We'll post that. It comes back with an ID. Subscriptions can be updated by doing a put on them. You can delete them to get rid of them, and you can also list them by doing a get on /subscriptions as well. Okay, so now we're going to go back to Alice's API. And so we haven't sent any messages yet in this transaction. And Alice is going to send a message with the banana tag. And for the sake of the example, we're going to send a JSON object payload this time instead of just a string. And here I've defined the group as just org1, and this is Bob. So this is going to be a private message, unpinned, request response from Alice to Bob. Hopefully by this point, that makes a certain amount of sense. So we're going to send it. Latency was a little bit more there, not too bad. We're running a lot of this locally. So, and then we can see, if we scroll all the way down here, this is the payload that my request bin responded with. So it said 200 OK. It's apparently they're using an Express web server because it's powered by Express. So we can see their headers are on there. And then the response body was just success true. So now if we hop back over to our browser and look at our request bin, we can actually see our request that we made there. So it was a post to /banana because that's where we define the subscription to send those things to. And we can see this is our JSON payload that Alice sent to Bob. So this is how, if you want a subscription is how, like, if you want a webhook to send requests to your application to actually handle them and execute your specific business logic that you have for that type of message, that's how you can do that. Subscription, it's worth noting that subscriptions are not inherently tied to the request response model. A subscription could be a webhook as well. I don't have time to demo both of them, but just wanted to kind of demo those pieces. So we could look, and now we see Alice has 5 messages. Bob has 5. Poor Charlie, he's only got 1 over here. So that is it for the hands-on demo, and I'm going to switch back to my camera here. And I I wanted to conclude with, I had one more slide and I actually forgot to put it in my deck, but it's okay. It was just some text. So just wanted to wrap up with kind of describing what's next for Firefly. So in development right now, in very active development, are connectors for Fabric. That there's code up on GitHub that folks are working on right now, building that out. We're working on the Corda connector as well, coming soon. But I don't. In various stages of getting started are token support for fungible tokens and non-fungible tokens, and also support for custom on-chain logic. So that's kind of I'd say the near-term roadmap for big things that we know we need to have in Firefly that we are working on. I also just want to take a moment and just say, like, this is an open source community, and if some of the things that we've talked about here today or some of those upcoming things sound exciting to you, we would absolutely love to get you involved. So thank you for coming out to this meetup. Hopefully this gave you just kind of a good introduction to what Firefly is, some of the basic concepts with it, and enough that you can kind of get your feet wet with the CLI, try it out. I'm on Rocket Chat through Hyperledger. I'm also available to email. So, if you are curious about getting started, please reach out. And I would love to help get you plugged into the Firefly community. And we would love more contributors, and we would actually love maintainers as well as we advance the project. So definitely want to get people plugged in and involved. Thank you very much. And I will, we've got about 5 minutes left for some Q&A, and then I'll hand it back over to John after that.
Yeah, great presentation, gentlemen. That was really informative, and it really looks like a great piece of the software stack to leverage on Hyperledger. One of the questions I'll have, and then we can look at anyone else who wants to maybe come off mute and ask the question directly, is just in an enterprise setting, it sounds like this would be very applicable to maybe the property insurance world, where there would be a claim that would be submitted by a customer, and they would say, okay, we have a claim against our house insurance, and then the insurer would review that, and then they have a public database, which is the Cli database, and they would be able to go ahead and share that claim history with the public database once the internal messaging was all straightened out and the claim was approved by the insurance company. Does that sound like a good use case?
I think it sounds fantastic.
It does, and one of the sponsors of the Firefly project was actually the institutes, particularly the Rishstream collaborative that's part of the institutes, and that's actually a network of a very long-standing network of insurance companies. So we certainly have a lot of experience how it applies in that industry, and it's a really any industry that has a problem of siloed data, of there's some kind of something that's happening in the real world that needs to involve multiple organizations, and different parts of that need to happen between those different organizations. It's a great candidate for a multi-party system. It's a great candidate for blockchain, and you're squarely in the wheelhouse of what Firefly's grown up trying to solve. It's not just about security token offerings, right? The world of blockchain, the world of problems that DLTs can solve in a way that was impossible before DLTs came along is really wide. And I think that was a fantastic example. There were examples in healthcare was one that came up on the chat. There's great examples there. There's examples in supply chain. You just think about how many steps it takes to let a ship leave port or post-trade settlement, and how much of that is about private, very sensitive data exchange that's kind of backed by blockchain, but it doesn't all go on the blockchain. It just never does. Those are that's the sort of problems that this technology has sort of grown up trying to solve.
Yeah, I see extreme value in that, and I agree with you when you're talking about, an industry consortium and multi companies involved. There's obviously private data that they don't want to share with the consortium. However, there is data that they do want to share with the consortium, and I really think that your application layer really enables both components there. Okay, perfect. So, and I appreciate both of you and the team answering all the questions in the chat. And at this point, if someone has a specific question that maybe wasn't covered in the chat and they'd like to come off and ask it directly, just go ahead and let me know. And if you want to raise your hand, great. If you want to just come off chat, that's perfect. It sounds like here's Romaro, and he would like to be a contributor for Firefly. And I think, you know, anytime we're talking about a labs project, we always want to make sure we're getting, you know, contributors and maintainers engaged early to ensure the success of the labs project. So maybe you want to talk a little bit more about, you know, how to get people onboarded. We put a lot of stuff in the chat, and maybe even
Absolutely,
you know, skill sets and everything else that you might be looking for.
So I'm pulling up a link here real quick to the our Rocket chat, which is probably the best place if you want to chat with folks on the project.
Mm-hmm.
That's the best place if you want to engage in real-time chat with maintainers and other contributors on the Firefly project. You can find us all there. So if you have a Linux Foundation ID, it's a free account you can sign up for. If you don't have one, sign up there and then join that channel in Rocket Chat and be happy to chat about how to get plugged in. In terms of skills, a lot of the core is written in Golang, so that's obviously super helpful. But you know, there's a lot of different pieces, a lot of different technologies. Obviously, we're working on Corda. It's you know, Java. So trying to think of what other.
Yeah, so maybe I'll take this one a little bit. So it's a microservices architecture.
Yeah.
That's really, really important to understand about this. This isn't just a Go project. Mm-hmm. It would be impossible for it to be the umbrella of things like Corda if it were. And already there's different components that are written in different languages. So there's a data exchange that's part of the open source. It's very pluggable for lots of different technologies. The data exchange implementation that's available that uses HTTPS and mutual TLS, that's written in TypeScript. The UI, well, that's all React and TypeScript. So it's not a community that you can only be involved in if you know Go for sure. And in terms of skills, it's a huge range, right? Because some of the skills are, I'm involved in a community which is solving great problems for enterprise, adoption of DLT, and people are struggling to use us. Applications are struggling to build on us. Could Firefly be a way that maybe it becomes 100 times easier for someone who's never heard of blockchain to use my tech? That's another way to get involved. It isn't just necessarily about building the core and the things that are Firefly specific. Taking a tech, we're working with lots, Hyperledger Avalon, Hyperledger Cactus, Hyperledger Besu, as well as Fabric. Like these communities, actually working out how that plugs in is another great skill set to bring to the community.
Yeah, thanks.
Yeah, and I appreciate that as well, because we always are talking about the Hyperledger greenhouse. And I know there's been a lot of focus in this presentation around Hyperledger Fabric, but maybe you can talk about a little bit more about those intersection points with the rest of the greenhouse, and maybe even have to tap into that community and bring them on board with Firefly as well.
Yeah, I'll take a minute on that one. I know Jim's on the line, and he's probably thinking about talking. People who've been in Hyperledger for a while might know Jim from previous lives. He's one of the core contributors on Firefly, and has already been talking lots with other projects. Besu, because actually the most advanced of all of the blockchain connectors in the Firefly stack at the moment is the Ethereum one. So there's a lot of collaboration that's already happened there. For many years, we've known the Besu guys inside of Kaleido since the very earliest days there. And then a really interesting space is around identity, how identity plugs in. And then another one is around the interop side and also zero knowledge. And I know there's been an active collaboration with Cactus on those two topics as well. So being a sort of melting point for technologies, being a way to make technologies accessible, is just such an important part of Firefly. So we really want to be that place where technologies come together to help break down, like, there are a few silos out there, and actually, you know, being able to help break some of those down. That's something that everybody on the Firefly project is really passionate about. That what we need is really good production blockchain projects more than anything else, right? We need success. We need use cases that show value. And that's probably a little bit more important in this stage of the journey than like which individual technologies are used here or there.
Yeah, no, that's perfect. And it looks like Alfonso's weighed in and, you know, breaking the silos, which is, you know, really what I think the greenhouse is all about is, you know, how can we cross-pollinate and help each other out in the different projects? Because there's a lot of expertise that covers all around Hyperledger, and then being able to pull in resources that may help the Firefly project is a great way to cross-pollinate. Okay, perfect. Let's see if anybody else would like to answer or ask a question for the Firefly team on the session here. And I just feel like, you know, we want to make sure that a good way to
John,
engage is going to be with the chat.
I think
Here's a good opportunity to talk to the team directly. So Jim, go ahead and weigh in.
Yeah, sorry, John. Devendran still has an outstanding question from the chat.
Okay, perfect. And Devendran, I see it here. It says, am I right in thinking that the subscriptions, topics, and etc. are used to integrate with enterprise-wide messaging systems like Solace?
That's a fantastic question. So there's two sides of this. Right? This is a really important and it's a really astute question. So you think about a technology like Solace, or you know your Tibco AMS or your IBM MQ series or whatever it is, right? Or ActiveMQ, Artemis, RabbitMQ, whatever. These technologies have existed for a very long time and they're exceptionally good at reliable enterprise-to-enterprise messaging and also within the enterprise. Firefly has connectors on both sides, plugins on both sides. And your enterprise network as it builds is going to need both of those. So one organization on their own in the system might use Solace. Maybe they're, you know, it's a financial organization. They've got 100 systems connected together in a trading ecosystem. Every one of those 100 systems uses a private Solace box inside of their organization, right? Then, yes, absolutely. On the sort of front side, the API side of Firefly, you'd plug in Solace. You might do it over WebSockets or webhooks, or you might contribute to Firefly an event plugin for Solace using the lower level, you know, implement it directly. And that's great. That organization then in the ecosystem, like there's 10 organizations, one of them's using Solace, that's brilliant. There's also the integration at the other side. How do those 10 organizations want to privately share data with each other? And that's where the private data exchange plugin comes in for Kaleido. And that's the other side. That's the sort of the back side of Firefly is the integration to what's the cross-member private pipe. And each network's going to have to choose one. We've never seen a network that's got built without choosing any. The blockchain's never been enough. In the experience that the people involved in Firefly have seen, we've never seen one evolve without one. But it may not be just because one organization is using Solace that everyone's going to connect together through Solace. One organization might be using Solace internally, then the organizations might be connecting together through ZeroMQ or something like that, right? And Firefly is then that bridge that allows the developers who only care about REST APIs, integration, and Solace because they're in their organization, it's their bridge to the rest of the ecosystem. And they don't have to worry about the fact that, well, that ecosystem's working on something else, right? They don't have to, And this is the problem in enterprise blockchain, is you end up in a situation where if every organization has to learn the tech stack of every other organization, you're never going to get anywhere. You need a way to make the job of joining the ecosystem easier for each of the participants, but still enterprise friendly. Sorry, that was a long answer, but that question tickled me because it's from my background. I thought it was a really great question. I think you've really understood kind of the types of problems that Firefly is trying to solve.
Yeah. One other question I'd have for you is just around, deploy once, deploy too many. And so I don't know if you're familiar with the Accord project, which is a Linux Foundation project around natural language smart contracts. But their philosophy has always been, deploy once on the Accord project and then be able to plug it into the blockchain architecture that best meets your needs. So do you look at Firefly as being that deploy once, deploy many type architecture going forward, or what's your philosophy there?
I have a personal view, and maybe open it up to some others. So far, all of the value in enterprise, pretty much exclusively, or maybe it's changed a little bit in the last year, has been in building islands, building private networks that have a group of organizations and a DLT or set of DLT technologies and private exchange that allows those organizations to talk to each other. And there's this fantastic innovation on the use cases, the applications. Organizations have put a huge amount of effort to building enterprise applications that solve a problem. At the moment, they're also building those inside of one of these ecosystems, and they're kind of locked inside of them. I think one of the next steps for our industry as a whole is for these bridges to start getting built between ecosystems. One of the ways that bridges is going to get built, of course, is going to be using DLTs that are shared, being able to go up to Ethereum 2.0, across and down to Fabric, right? Whatever, at the DLT level. Another way that we're going to see bridges getting built is when applications can be deployed in a decentralized way to multiple ecosystems. And being able to build an application on top of a set of APIs like Firefly could really allow you to do that. If we standardize things like fungible and non-fungible tokens, and I've built on that plus data exchange, right, that's the small building blocks that are already in flight for Firefly. Maybe I could build an application that I could deploy to 10 business ecosystems rather than once. And suddenly the amount of payback I get for that really heavy investment that I'm doing in an enterprise application, it makes more sense for me to do it. And we'll get more innovation and people will get more payback. And then, the rising tide lifts all boats. Everyone will do better when you can get more success more quickly out of building to blockchain. And that's certainly the journey that all of the other technologies waves like AI and other similar ones have taken in the last few years. It becomes more interesting when you stop talking about the tech, you start talking about the use cases, right? We talk much less about AI than we did a few years ago. Not because AI isn't fantastic, but because everyone understands it now, and we're now building use cases on top of it, and it's achievable. We need blockchain to get there.
Hey, this is Jim. I'll add to that, John, that I think the question is around two different approaches between what is being done with projects like Accord. I think to a certain extent, them or composing early days of Hyperledger, where they start with the common language for domain specific language. Overall, we spec out the whole network. Versus Firefly, we focus on APIs and components, which makes it, in our opinion, very flexible to support all sorts of things in the future. All of those projects, Demo and Composer and Accord, they have to work across the whole community from day one to make sure the language they define will be able to support evolutions, and that's a difficult task. It's a very interesting approach, but Firefly a pretty different approach. Just want to add that aspect.
Yeah, no problem, Jim. And I just wanted to kind of just touch base on that because I'm familiar with the Accord project and I'm familiar with what Firefly is doing, and just kind of wanted to discuss the way the two projects are approaching how to interface with multiple blockchains that may be out there that an organization has adopted. Okay, perfect.
Looks like Amit has a question about. Oh, yeah, go ahead, John.
Yeah, let's go ahead and take his question. So he wants to know, does Firefly work across versions? Org 1 uses ETH, but Org 2 started with ETH 2. So maybe take that and let's discuss it.
Yeah, great question. So, as Peter was talking about with the plugin architecture of Firefly, there are certain parts of Firefly where each member of the organization can have a different implementation of how they want to interact with the network. There are some that do have to be the same though, and the blockchain is one of those. So while Firefly is designed to have a pluggable blockchain layer, you could plug in Ethereum, you could plug in Fabric, you can plug in Corda. It is a shared ledger. So all of the members of the network need to have the same ledger. They all need to be using the same blockchain, and they would each have a blockchain connector connecting to the same blockchain.
Just one really small caveat, of course, if you've got a technology, which is true in Fabric, true in Corda, where you can have lots of individual ledgers on the same technology platform, like lots of Fabric channels or lots of peer-to-peer connections in Corda, that's supported. It's only, but it does, at the moment, a restriction, which could be lifted with community contributions, is everyone needs to be using the same blockchain tech, and they choose which ledgers they're using. Yeah. But today, there's no ETH 2.0 plugin, so it would be very, very cool if, Amit, you were interested in contributing that one. That's the topic dear to my heart.
Yeah, and that's always the thing, is the space is going to continue to evolve. So, his question is relevant in the fact that, ETH 2 will appear at some point and we'll want to connect to it. Okay, perfect.
One thing that I would say...
Go ahead.
I just want to say, one thing is that you get a private copy, your view of the world in Firefly. It's subtle, right? But you've got your own database with your view in the world, and that's all history that's happened. So if somebody contributed a plugin in the future that allowed multiple blockchains to connect into one Firefly, the Firefly model would let your view of the world encompass transaction histories that span multiple blockchains, because it's about everything that you've seen. It keeps a cached, fast copy of everything you've seen in the past. So it is suitable to that sort of future state where we see organizations needing to be the boundary of various different places. The technology doesn't do that today, but the model is quite suitable to that in the future.
Jess had a really interesting question here, which I've been thinking about. I never thought of this before, but could you have two different Firefly networks, each using different blockchain, but connected through a Firefly as a gateway? I suppose you could. It's a rather fascinating thought exercise. And it would probably come down to some orchestration between the Fireflies in the separate networks, perhaps through subscriptions to transmit events back and forth. I need to spend a little more thought on that, on some of the implications there, but that's an interesting thought.
Yeah, there is a stream of work that Andrew and Jim are working, leading on tokens, and that stream is considering more than just the tokens within one chain. It's also thinking about bridges, and of course, there's lots of things that you could bridge, but tokens have characteristics that make them easier to bridge than others. Because what Nicko was discussing there, you've got two different ledgers. Being able to move data between them is one thing. Being able to move assets so that they no longer exist in this chain and they do exist in this chain, or data, that's a harder problem. And Firefly, this is a great example of what Firefly is not trying to do. Firefly isn't trying to be the place, the community that would build the super sophisticated bridge contract, but it is trying to be the community that could plug in things like hash time locks and netting and other ways to do settlement, that you could plug that in and provide examples in the place where you could plug them in, and then an API to standardize what state transfer might look like or what token transfer might look like.
Perfect. Okay, looks like Faisal has a question for us here. Is it possible to attach a file like a PDF with a transaction message in Firefly without putting it in IPFS? And he wants to keep the
absolutely.
Firefly private between himself and the counterparty. So go ahead, Nicko.
Yeah, so that's what the private data exchange is all about. So you can most definitely, the same way that we, in the examples that I walked through, I didn't show attaching a file, but instead of putting just a JSON string in that payload, I could have done a file upload there, and that would have not gone to IPFS. That would have been transmitted over the private data exchange, which in the current implementation uses HTTPS with mutual TLS, and that would have been totally excluded from IPFS there to keep the data private.
Perfect. And I think that kind of leans into that property insurance example that I gave, where you might have the full claim history that you want to share internally, and then finally when you say, okay, we've paid out a claim of $20,000 for a new roof on this house, then you're going to go ahead and put that on the public clue database for property insurance claims.
And there's this subtle thing, a question that often comes, maybe someone's going to ask it, is like, but isn't that what things like channels are for? Like you can just have a transaction history that's just between these parties. The experience that we've seen is that they're fantastic and really helpful, but they don't solve the full problem. Data like 100 megabyte PDF is still going to be not particularly suitable to putting inside of the DLT. Data that you might want to delete or might have regulatory reasons where you need to delete it in the future isn't particularly suitable to the DLT. And then here's the fun one. Often business transactions need to be one consistent business transaction, and different people are allowed to see different parts of it. The assessor may not be allowed to see the same data as the insurer in an end-to-end business transaction, but they're all one contiguous set of events. So they might all want to be on the same blockchain ledger. They might want to all be in the same channel. And Firefly embraces that some data can be shared as part of one stream of events, can be shared with different parties at different stages along the journey, and still be backed by the same ledger.
Perfect. Yeah, that makes perfect sense, and I'm glad you addressed that, because I'm sure that there's probably somebody that has a question about it either on the live stream or what we have for the group assembled here. Okay, any other questions that we can ask for the team here? This is a great opportunity to really get their expertise and learn more about the project, and then engage and be a maintainer or be a contributor to the Firefly project. Okay, I'm just going to check here on the YouTube live stream. I'm not seeing anything specific coming through there. So if anyone has any other questions, let's go ahead and surface them now. And if there's not any
question from Amit.
Go ahead. Yep.
Yeah, we had a question from Amit about what is required to be a maintainer. I'll take that one, and the short answer is I'm in the process of documenting what that looks like, and feel free to reach out either by email or Rocket Chat, and would love to get you plugged in. It's on the to-do list for the project as a whole to document what is the process of becoming a maintainer, and it won't be an onerous process, but we do know that it's something that needs to be documented. But let's chat. Super excited to hear that you're interested.
And it's always going to start with some contributions, so we can get you plugged into that straight away. There's lots of areas that I'm sure you could bring skills and would be a great part of the community.
Okay, and then Jess has another great question here. So the question is, can you speak about what your expectations are for the on-chain logic?
I'm going to take that one a little bit. So Maybe, Jess, the first thing to say is if you go and look at the project and you look at the on-chain logic that you'll find, you might find an early PR around integration of some token logic, but the stuff you'll find in the main branch there is the simplest smart contract logic you've ever seen. It just emits an event. And one of the perceptions we're trying to address is that's because we don't care about on-chain logic within Firefly. It's not that at all. It's because we don't want to have any perceptions about the on-chain logic. We want any on-chain logic to fit the model. And one of the reasons why we haven't already done custom on-chain logic is because another really core principle is it's going to work across 2 blockchains. So before we define the model in Firefly, because it is defined in the Ethereum connector, there's a great REST API and event streaming technology in the Ethereum connector for any on-chain logic. Before we define how it rolls up into the Firefly umbrella, we want to make sure that at least one other blockchain is at the same level. So the work that's happening on Fabric at the moment is about getting a parity between what you can do on Ethereum and what you can do on Fabric so that we can roll those up to a standard model of what invoking any on-chain logic can look like at a simple REST API level. And we just don't want to rush and then end up, we accidentally, only one leg of the stool works because we built that one without thinking about the other one. So that's the only reason why you won't see custom on-chain logic. But from a project perspective, anything goes. It's very important to us. And it's the same for off-chain logic. So off-chain logic can be anything you like. It doesn't need to be deterministic. It can be human processing. It can be business project logic. It can be Node.js. It can be Go. It can be Java. It can be trusted execution. It can be deterministic. It can be zero knowledge proofs as well. So it's the same for off-chain logic being pluggable as well as on-chain logic being pluggable.
Perfect. And it looks like Jess really appreciated that great answer. So thanks for doing that, Peter. And this has been a wonderful session. If anyone has any closing questions or comments, feel free to post them in the chat. And if not, I really want to thank the Firefly team and Peter and Nicko for joining us today to go through, how we can get involved. And what I want to make sure of is that everyone also knows we're going to have some great meetups coming up, which are around both what Alfonso talked about earlier. And Alfonso, thanks for joining the session today. And then I also want to recommend, if you're interested in what's going on in the blockchain job space, to join the second of our 4-part series. It's going to be hosted by the Hyperledger Boston meetup and Jim Mason around, blockchain employment and what opportunities are out there. So we're going to go ahead and wrap up here. And I hope everyone has a great day. And David has done a great job of always helping out the Hyperledger meetup community. He posted a link of where the recording will be in the chat. And then we'll also go ahead and share the presentation deck with the attendees as well after the session. So thanks, everyone. Have a great day. Any closing remarks, Peter and Nicko? Otherwise, we'll wrap up.
Yeah, just wanted to thank you again, John, for organizing this, and thank you to all of you who have attended, and just super excited about the excitement of the community, and really looking forward to helping get people plugged into this project and get some more contributions from the community. So super excited, and just thank you again for the opportunity. This was a lot of fun. Appreciate it.
Thank you so much, everyone.
Okay, everyone, have a great day, and we'll catch up soon. Take care.